Welcome back. In this video, we are going to solve problem 13-7 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by RC Hibbeler, 9th edition. So statement is a 2014 T6 aluminum alloy hollow circular tube has an outer diameter of 150 millimeter and inner diameter of 100 millimeter. If it is spin at both ends, determine the largest axial load that can be applied to the tube without causing it to buckle. The tube is 6 millimeter long. So let's start with the solution. As we know that the largest axial load by using Euler's formula, this largest axial load is represented as P critical, and this P critical is equal to pi square E multiplied by I divided by LE, where E is modulus of elasticity, LE square, where E is modulus of elasticity, I is the second moment of inertia, and LE is effective length. So we will first find the moment of inertia I, and for that we know that for hollow circular shaft, that is equal to pi by 4 multiplied by R outer power 4 minus R inner power 4. Okay, so just plug in the value pi by 4. What is R naught? R naught is outer radius. So we have been given outer diameter, which is 0.175. So diameter divided by 2 will be outer radius. So 0.150 divided by 2 is 0.075. So that is outer radius power 4 minus inner radius. So inner diameter is 0.100. So inner radius will be 0.05 power 4. Okay. So when you solve this, that I, so let's solve it. 0.075 power 4 minus 0.05 power 4 will be this one, divided by 4 will give you pi multiplied by 0.1230456347, and the unit will be in meter power 4. So if you simplify it, so what you are going to get is that this will be equal to 6.347 into 10 raised to power minus 6 meter power 4, and it will be multiplied with pi. So I will multiply it with pi, multiply with 3.1417, that will be equal to I we will get will be equal to 1.994 into 10 raised to power minus 6 meter power 4. So let me check it. You can see that here this is 1 2 3 4 5 6. So actually this is 19.9. So let me correct it. This is 19.94 into 10 to the power minus 4. Now we will also find the area as well, and we know that area is equal to pi r naught square minus ri square for the hollow section. So put the value pi multiplied by r naught is 0.075 power 2 minus r inner is 0.05 power 2, and the unit will be in square meter. Okay, so let's solve it. A is equal to 0.075 square minus 0.075 square minus 0.05 square, that is 0.3. Let me write it, 0.003125 multiplied by pi, and the unit will be meter square. We can also write this area is 3.125 into 10 raised to power minus 3 multiply by this pi, and unit will be square meter. Now what we are going to do is that we will get the value of E from the property table, from average mechanical property table. E for that material. So let's move and find the E value for that. So you have to go at the end of the book and you have to choose average mechanical property. In that you have to look for the material. So the material was which one? The material was 2014 T6. So 2014 T6, and here you can see the E value is 73.1 gigapascal. So let's move back. 73.1 gigapascal, or that is equal to 73.1 into 10 raised to power 9 Pascal. Now what about effective length? So effective length is equal to K multiplied by L, where this K is can be obtained again from the book. You have to go to this chapter number 13, where you have to look for, I will show you now. Here you can see in the question it was given both ends are pinned. So this is pinned, so K is equal to 1. So I will write that 1 multiplied by length was given as 6 meter. This is 6 meter. So that will be, effective length will be 6 meter. Now put all the values, in P critical. So you will get this pi square multiplied by E is 73.1 into 10 raised to power 9 multiplied by I, which is 19.94 into 10 raised to power minus 6, divided by this length, which is 6. So L square is 6 square. Okay, now we will solve this. So again you can see 3.1417 square multiplied by 73.1 into 10 power 9 multiplied by 19.94 multiplied by 10 power minus 6. And if we divide our answer by 6 square, so we will get this value, which is P critical will be equal to 399,640.463, and that will be in newtons. And again, if you write it like, if you divide it by 1000, so it will be 3399.64 kilo Newton. So this is the critical load under which this hollow tube will not fail. Now what we will do is that we will check critical stresses, that how much the stresses will be generated. So critical stress, that is, we can say that Euler's formula is valid only when your critical stress is greater than yield stress. So let's calculate critical stress. So we know that critical stress is equal to critical load divided by the area. So critical load is 399.65 and critical area is this one, which we have already calculated, this one. So 3.125 into 10 raised to power minus 3 multiplied by pi, and unit will be square meter. Now we will calculate it. 399.65 divide by 3.125 multiplied by 10 power minus 3 multiplied by 3.1417. So you can see that is equal to 4706.62, and unit will be kilonewton per square meter. Okay, now we know that critical stress is 4706.62 kilonewton per square meter is Pascal, so kilopascal. And again, you can see that if you go towards this point from this 1 2 3, so what you will do is that you can also write it as 407 40.70662 into 10 raised to power 3 kilopascal, and this 40.70 into 10 raised to power 3, and kilo is also 10 raised to power 3 Pascal, so that will be equal to 40.70 megapascal. So this is your critical stress. Okay, now we will check what is the yield stress. So for that I have to go to the end of the book. Here again we will go to the property table, average mechanical property, and from here you can see again that this yield stress is which is 414 megapascal. So yield stress is 414 megapascal, and you can see that your critical stress, which was 40.70 megapascal, is less than yield, which is 414 megapascal. So it means that our design load of critical load of 399.64 is correct. And this was all about this problem 13-7. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.